There is two ways we can plot input and output characteristics of common emitter configuration of transistor using multisim. One way is just doing few clicks and the characteristics is ready. And the other way is like doing it on an actual hardware board. In this video, we are going to explore both these methods. Not only both these methods, but for method 1, I'll share some tips and tricks how to control graph property through multisim. And in method 2, I'm going to share some tips and tricks about Excel sheet, how to plot the graph and how to control the property of the graph. So all this bunch is in this video, so do not forget to watch a full video. So now let's get started. Now we are going to plot input characteristics of common emitter configuration of transistor. You know what? Amongst these three configuration, the common emitter configuration is one of the most used configuration. And BC548 transistor is one of the most commonly used transistor in all laboratories. So what we are going to do, we will use common emitter configuration and BC548 transistor. So that is why we are doing common emitter configuration and BC548 transistor. So first of all, let's prepare the circuit for the experimental setup. From this toolbar, go to transistor, NPN and BC548. So this is our transistor BC548. So our simple circuit is ready. So this is V1 voltage. We will change the label. Instead of V1, we'll call it VBE, base emitter voltage, and this is V2 voltage. So instead of V2, we'll call it VCE, collector emitter voltage, and the maximum value of this voltage will be 20 volts. So now this is our transistor, this is resistance, VB voltage, VC voltage. Now we'll go to simulate. In simulate, analysis and simulation. In analysis and simulation, here there is DC sweep. So in DC sweep, go to analysis parameter source 1, and in source 1 there are two sources that we can see, VBE and VCE. Source 1 is the voltage which we want to regulate. Basically the input characteristics is in between base emitter voltage and base current. So to plot these characteristics, what we are going to do, we'll set collector emitter voltage to one particular value and then we'll vary base emitter voltage and we'll observe the change in base current. So that is what the input characteristics is all about. So for that, in source 1 we are going to select VBE and we want to vary VBE voltage from 0 to 1 and at the increment of 0.01, right? It may be possible that in many of the application this use source 2 is unclicked. So for that you need to click use source 2 and in source 2 you need to select VCE. VCE we want to select from 0 to 20 volt and we want to give step size of I think 5 volts, 5, 10, 15 and 20, right? So these are the increments that we want to give to VCE. After this, go to output. In output, these are the different parameter which you can plot. So out of this, which we want to plot the base current. So just select base current and add it on right hand side. Once it is done, everything is done. Now you have to do just a click. Run the simulation and there we go. Now here you can see different input graphs. So now let's understand this graph. This red line indicates when VC voltage is 0. It is mentioned over here in left corner. So when VC voltage is 0, when we change VB voltage, according to this voltage, the current will gradually change like this. And then this blue line indicates the VCE 20 volt. If you just unclick it, this line will disappear. So now you will be able to see this line, right? All of these lines are overlapping, and that is why you are not able to see all these lines. So once you unclick this, the 10 volts line will be visible. When you unclick this, the 5 volt line will be visible. So now the line of only VC is equal to 0 volt is visible. When we click this 5 volt, the line of 5 volt will be visible. The white marking represent the selected line. If you select this white mark shifts over here, and when you select this white marks shifts over here. Now let's suppose if you want to change the parameter of this graph, just double click this thing, so a window will pop up. So here it shows the title of the graph. If you want to change the title, you can change it from here. The other properties which you can control is grid. Instead of this dot, if you want to have a solid line, just click solid and apply. So here you can see the line is changed into solid. Let's get back to the dot. So now it is dotted. You can even change the color. So this is how you can regulate the grid. Now again we are going back to this normal grid. For example, if you want to turn off this grid, just click over here, grid on, and then apply. So the grid will be disappear. If you want that grid back, just click grid on and apply. The grid will be back. If you do not want to see these legends, just unclick it and apply. All the legends will disappear. Now let's go to the next step, traces. In traces, the first thing is trace label. The graph that we have selected is of this VVC is equal to 5 volts, right? So if we want to change the label, we can change it from here, VC is equal to 5, and then we'll apply. Once we apply, you can see the change over here. So whatever name you want to change, you can change it from here. If you want to change the color, you can change it from here. Let's make it green and apply. So the color of this graph has been changed. Let's make it magenta again. You can even change the width of the trace line. For example, let's make it 5 and apply. So the trace line has changed. So these are the parameters that you can control it from here. If you want to see the data point on this graph, then you just need to click show data point and select the shape of the data point. Let's make a triangle and apply. So all these small triangles that you can see on this line is of this shape. Let's increase the size so it will be easier for you to observe. So this is how you can increase the size of this triangle. Let's make it round, apply. So this is how you can change different properties of the graph. You don't want to see this? Now let's go to left axis. In left axis, it is all about this current axis. So if you want to change the name from this current ampere, we can change it to IB current, right? And let's apply. So it has changed to IB color. You can even change the font. There are varieties of font and so much configuration you can do in this graph. You can even set minimum and maximum range. Minimum range is -5 and maximum range is 2.5. Forget about e raised to something. So it's -5 microampere to 25 microampere. For example, there are total 6 segments, right? If you want to change that segment, let's make it 12 and apply. So it will give you more segments vertically, right? Now let's jump to bottom axis. Bottom axis is VVBE voltage V. So instead of this VVBE, let's make it VBE voltage and apply. So here you can see the name has been updated. Now from this total tick you can change the vertical grid line. Let's make it 20 and apply. So you can see the vertical grid line has been increased to 20 lines. So this is how you can control the graph properties, right? There are so many things we can do with this right axis and top axis, but right now we do not have any right axis and top axis, so we'll not cover these things. So now let's close this thing. So this is our input characteristics. Now again close this thing. But now before moving ahead, I want to ask you a quick question. Let me know whether it is possible to control grid lines through the graph properties. What do you think? If you think we can control, then write the answer in comments below. I am waiting for your answer. Because if you can answer this thing, that means you have watched this video consciously. Now we are going to plot input characteristics of common emitter configuration of BJT using second method. And for that second method, we need to do some modification in this circuit. Before modifying this circuit, let me tell you what exactly we are going to do in method number 2. We'll keep collector emitter voltage constant and then we'll start changing base emitter voltage. When we are changing base emitter voltage, we will observe the change in base current. And that is what exactly we desire for. We want to observe the change in input current when we change input voltage. We'll vary base emitter voltage from minimum to maximum and observe the change in base current. Now we'll change the value of collector emitter voltage and repeat the same process. So all of this we are going to do now, and at the end I am going to show you how to plot graph in Excel sheet, an attractive graph in Excel sheet. So do not miss those things. Stay tuned to this video. Let's move ahead. And now to do whatever we have discussed, we require a multimeter. So we'll grab it from here, we'll place it and connect it over here. Double click it, click on emitter, click on DC and close, and then remove this link. So this has become emitter. Take another multimeter, place it over here, positive on base and negative on emitter. Double click, click on voltage and DC. Close. Similarly, we'll connect emitter and voltmeter on output side. So the circuit is ready. Now here there are so many instruments. I will make a separate video explaining working of all those instruments. So if you are interested in learning the working of all these instruments, how actually we can use all those instruments, then you can check out my video lecture series on Multisim tutorial. The link is in description below and above here in card. Later you can check out all those videos. So now let's jump in it. This is our ammeter. We'll place it over here. This is voltmeter. So we'll place it over here. Ammeter, voltmeter. Again, this is voltmeter and this is ammeter. Right? Now here, instead of this VBE, a DC voltage source, DC power source, we need to change it. Just right click it, replace components and go to signal voltage sources, DC interactive voltage source and place OK. Double click it, maximum voltage we want to keep it as 10, minimum 0 and increment we want to make it as 1%. Place OK. Why we did this? Because we want to change the input voltage frequently. Instead of this signal source, if we have kept DC source like this, then every time we need to double click it and change the value. But here what we can do, just press A button and you can see I am frequently pressing A and will be able to change voltage here itself. So we do not need to interrupt the simulation. Simulation will keeps on going and we can change the value of A. Now instead of keeping this VC 20 volt, we'll make it 3 volts. Okay, and now we are going to take readings. So for that, let's run the simulation. So you can see at 0 volts the current is almost 0. This is the current, the base current. Now we'll change the input voltage. So from the 0 we'll make it 0.1 and observe the change in current, right? Now make it 0.2 and observe the change in current. 0.3, up to here the current is in picoampere. Now after this 0.3, current has increased 1000 times from picoampere to nanoampere. 0.5, again 1000 times increment in current from nanoampere to microampere. Though the previous current we will take it as 0 ampere because nanoampere and picoampere is almost tends to 0 current. So now at 0.5 the current is 1.8 microampere. 0.6 it's 5.3, 0.7 9, and when we'll keep on increasing at 1 volt the current is almost 23 microampere. Now we'll stop the simulation, we'll open the source and the increment will change it to 10% because now onwards we want increment of 1 volt. Let's again run this thing. So after 1 volt it's 2 volt, then 3 volt, 4 volt, 5, 6, 7, 8, 9 and 10. So what we did, we have seen the change in current from 0 volt to 10 volt. After that 0.67 mark, the current had started increasing rapidly. This was with 3 volt VCE. Stop this thing, instead of 3, let's make it 9. Okay, and I'll repeat the full process. After 9 volt, we'll go to 18 volts. Stop the simulation. It's 18 and run it again. So we have changed the value of VC 3 times and taken all the readings of VBE versus IB. So now let's jump to Excel sheet. Stop the simulation and go to Excel sheet. So these are the readings for our experiment. Different VC voltage and corresponding to that voltage we have found different VB versus IB readings. So these are the readings of base emitter voltage and these are the readings of base current. Now what we'll do, we'll select this data range, go to insert and recommended chart. In recommended chart, just observe which chart you want to plot. This scatter chart looks nice and appropriate. So let's OK, and this is the characteristics. Just make it a little bit bigger. So from this diagram you can see the input characteristics of common emitter configuration BJT looks similar to the forward characteristics of diode. That experiment also I did in the same manner. If you want to learn that thing, then the link of that video is in description box below and above here in card. You can go and check this out. Now let's modify some things. Title of the chart. If you want to name the axis, just click over here and axis title. So IB current is in microamp and VB is in volts. If you want to change the style of this graph, just click over here. You can select whatever style you want to choose. And make your graph looks more attractive. You can go to this color and you can select your required color palette. For example, if you want to go all blue, all green, whatever color combination you want to choose, you can select it from here. Right? So this is how you can customize your graph in Excel. Now let's go back to the Multisim. Now you tell me which of this technique you find more handier, the DC sweep one or with Excel. Do not forget to write that thing in comments below. I am waiting for your answer. And if you have found any query in this input characteristics, do not forget to ask questions in comments below. So this is how you can plot the input characteristics of common emitter configuration of a BJT. Unfortunately, the length of this video has become so long. And thank you for watching this much of long video. But I have promised you to give you output characteristics as well. But now it is not in this video. But I am making sure that the output characteristics will be very next video to this. And the link for that output video will be on end screen in description box below, and you can find it in above here in card. And yeah, if you want to ask me anything, I am out here on Instagram, on Facebook, on Telegram. You can connect with me on any of the platform and you can ask your personal questions to me. I'll try to sort those questions as soon as possible. So see you in next video of output characteristics of BJT transistor. Bye bye.